Hello, this is Harry Does Data. I'm Harry Norton, and welcome back to my series on R programming for beginners. Today, we're going to take a look at data structures. It's not often that you'll want to work with just single pieces of data in R, so it's useful to be able to group them into data structures. These then allow us to use these pieces of data more easily. Once we've taken a look at data structures in general, we're going to dive into the simplest of the R data structures, vectors, before we then look at the rest of the data structures in the next couple of videos. So, let's get into it. But before we do, don't forget to give that like button a quick tap and subscribe to my channel so that you don't miss out on more great data science content. Data structures. So, as I mentioned before, data structures just allow us to store several pieces of data in a more organized way, and several statistical methods rely upon these data structures. In R, there are 5 main data structure types. These vary based on how many dimensions they have and whether they are homogeneous or not. Something is homogeneous if it contains only one type of data, whereas it's heterogeneous if it contains multiple data types. Today, we're going to be looking at vectors in detail, but I'll quickly give you a brief outline of how each of these different data structures look. So vectors are the simplest type of data structure in R. As you can see, they are one-dimensional and homogeneous. So what this means is you can only have one row or column of data, and it must contain the same data type. So you'll see the first vector at the top contains only numerical data, and the third vector contains logical data. You'll often want to perform the same calculations or operations on multiple pieces of data, and this is what vectors allow you to do. Matrices, or the matrix data structure, are the next level up. They're two-dimensional structures, but are also homogeneous. So again, you'll see that they can only contain the same data type. Whilst vectors are only defined by their length, matrices are defined by 2 different size parameters, the number of rows and the number of columns. And then moving up one level further, arrays are similar data structures, but can have extra dimensions compared to matrices. There is no limit to the amount of dimensions an array can have, but they may begin to lose meaning and become uneasy to work with at certain levels. All of these 3 data structures, vectors, matrices and arrays, are vital to many different statistical methods. But when it comes to data analysis, it's often necessary to store different types of data within a data structure, and this is where lists and data frames come in. So lists are essentially the heterogeneous version of a vector. Here you see a list containing numerical, character, and logical data all within one data structure. And then one step further is a data frame. A data frame will often have headings, so first name, last name, over 18, and weight would be the headings. And then beneath this you can store data relating to those variables. As I said, we'll be looking at each of these data structures in detail over the next few videos, but in this tutorial we're going to focus on vectors. So here you can see my R file that you can find on my GitHub as usual, and it has everything that we'll be going through today to do with vectors. So we're going to start by creating a vector, then we're going to look at using sequences and repetition to create vectors, then we'll look at finding the length of a vector, sorting and subsetting vectors, and then any other vector operations and vector functions. So let's start with creating a vector. You create a vector using the C function. So if we just do help C or $C, you'll see that this combines values into a vector or list. So let's create a character vector here called employees. And we can fill this with the names of some employees. So Michael Scott, Jim Halpert, Dwight Schrute, and Pam Beasley. And if we run that, you'll see that over in our global environment over here, we have a value employees, which is a character vector with length 4. So it has 4 data points within this vector. And we could also run this, just run employees now to see this, the output of the vector in the terminal. So that's a character vector. Similarly, we can have a logical vector. So maybe we want something to say if they are a current employee, and we would define that exactly the same. So using the C function again, and now we would just have it full of logicals. So we can have false, true, true, true. Over here in the global environment, if we just run that, then you'll see we now have the current employee data point or current employee object containing a logical vector of length 4. And then, yep, similarly, we can have numerical vectors. So we might have an ages vector. And again, you just use the C function to define that vector. So I'm just going to copy these in here. So these ages are correct at the time of filming, in case you're wondering. And if we just run that, then you'll again see that we have an ages 1. I've called it ages 1 because of something we're going to do in a minute. So we have an ages 1 object, and it is a vector with numerical values and 4 of them. We can also create vectors using other objects. So if we just define a few objects here quickly. So age 1 is equal to 27. Age 2 is equal to 78. And age 3 is equal to 19. Make sure we run those. So now we can assign an ages 2 vector. Ages 2. And we can use those objects that we've just created, those numerical objects, to define this vector. So similarly, use the C function, and then it'll just be age 1, age 2, and age 3. And if we run that, you'll see that it has done exactly the same. So we've got ages 2 over here, and it's a numerical vector of length 3. And you can also use vectors to define other vectors. So we might have a ages vector that is defined using the 2 ages vectors that we already have. So the overall ages vector is defined using ages 1 and ages 2. And you'll see that all that does is it combines the values into one vector. So now we have one vector of length 7 to define all of the ages. We can also define vectors using sequences. There is a dedicated function called seq, S-E-Q. So if we just take a quick look at that, then you'll see that this is for sequence generation. And we have to provide to it a from, a to, and a by. So I'm just going to copy this in here to make it easier. So we can copy that, and we could go from 2 to 100 by 5. And if we run that, then you'll see that it has created a sequence from 2 to 97. So if it doesn't exactly reach the final number that you've provided it, then it will go until it like the one before that it gets to that number. So you see we have it here from 2 going up in 5s all the way to 97. Similarly, we can have sequences going backwards. So if I just copy and paste that, we could go from 99 to -15 in steps of -10 and run that. And again, you see we're going down in 10s all the way from 99 to -11. And if we look over here, there's also a length out parameter that we could define. So instead of defining the steps, we could define the number of points in the sequence. So if we just do something similar to before, so we'll go from 0 to 100, and we'll change, instead of doing by, we'll do length dot out equals 26. So we've gone from 0 to 100 in 26 steps, and this goes up in perfect values of 4. But if we say did 23 steps, then you can see here that it goes up in decimal values. Now, if we want to actually create a vector from this, then we need to assign the result of that function to an object. So let's just have myVec, and we can assign the result to myVec, and you'll see here that that saves that sequence as a vector. As well as using sequences, we can use repetition to define vectors. So let's take a quick look down here at the rep function. Oh, not replications, rep. And you see that this replicates elements of vectors and lists. We could do rep of x equals 4 times equals 100. And so this will replicate the value 4 100 times. And if we want to replicate more than one value, then we can replicate a whole vector. So we might do rep of x equals, and then define a vector here. So vector 2, 5, 7. And then similarly, we can do that 100 times. And you can see that's replicated the entire vector 100 times. Let's just reduce that down to say 4 times to make it a bit easier. And similarly, we can use repetition. Instead of defining the times, we could define each. And so this will replicate each number within that vector 4 times. So we should have 2, 2, 2, 2, 5, 5, 5, 5, and so on. Just like that. And again, we can define both of these things. So we could have an each and a times. So if we define both of those in here, times equals 4, each equals 4, you'll see that we get each number repeated 4 times. And then that is repeated 4 times, that entire thing itself is repeated 4 times as well. And just like earlier, if we want to actually create a vector out of this, then we need to assign the result of our function to an object. So now we have myVec is equal to the object, the vector that we just created using repetition. You don't have to define the vector within here. You could use an already existing vector object. So we could have rep of x equals employees, one of our vectors from earlier. And we might want to repeat that, I don't know, say 4 times. Oops, not defining rep, we're defining times. So these are 3 of the main ways in which you're going to create vectors, and they'll all be used in slightly different scenarios. So now let's look at some different ways that we can work with vectors that we have created. So one of the simplest functions, I guess, for working with vectors, you might want to find the length of your vector. So whilst, yes, it does say up here, you might need to use the length of your vector in another part of your code. So a function to find the length of the vector, very simple, length. So we can do length of ages, and that will tell you that the length of ages is 7. So moving swiftly on to sorting. So obviously you could sort a numerical vector into ascending or descending numerical order, or a character vector, you might order it in alphabetical order. And as we saw in previous videos, things like uppercase letters will come before lowercase letters in that kind of ordering. And so if we want to order a vector or sort a vector, it's very simple. We just use the sort function and give it an x value. So the x value is our vector. And the second argument that you can define is decreasing. So this is by default set to false. So that means it will be sorted in increasing order. So if we just do that, sort ages decreasing equals false, you can see that ages has now been sorted into ascending order. Note that this doesn't actually change the vector itself, it just returns another vector with the values in ascending order. But this won't actually be saved as an object, so you need to assign that to an object if you want to save it as a new vector. Or you could overwrite the existing vector, so you could do ages is assigned to the result of that, and that would overwrite the ages vector to then be sorted. And now we can just show you what happens if you change this to true. So true, now we have the vector sorted in descending order. And similarly, we'll just quickly show you what you do with characters. So a character vector type, say employees, the one that we created earlier, can also be sorted, and that has now been sorted into alphabetical order based on obviously the first letters. And similarly, you need to assign that to another vector if you want to save it, and you can change the decreasing argument to change the order in which you are sorting. Something else that you might want to do with vectors is subsetting. So you might want to extract specific values from a vector or a specific range of values from a vector, and this is where subsetting comes in. So the simplest form of subsetting, we could do ages, and then in square brackets you denote the index of the value that you want to extract. So ages 1, for instance, we'll extract the first value from the ages vector, which you can see here is 40, and as you can see, it returns the value 40. Or you could do ages 3, so ages 3, and similarly that extracts the third value from the vector. You can also use another vector to extract multiple values from a single vector. So we will define a vector in here, let's say 1, 3, and 5. And if we do that, then you can see that we extract the first, third, and fifth values from the vector ages. Again, if you want to keep these results, then you need to create a new vector. So let's create ages subset and assign the results of that to our new vector. And as you can see, we have now got ages subset with the results saved to it. You might not just want to extract values from a vector, you might want to replace values within that vector. So we could do ages and the first value in ages, and then we could assign a new value to that. So we could assign the value 0 to ages 1. And you'll see that that actually does change the vector straight away. So it changes the ages vector, and the value that was 40 is now 0. Similar to subsetting is logical subsetting. So logical subsetting allows us to use a logical flag to define which values we want to extract from the vector. So what I mean by this, you could extract values using a logical vector. So we have our ages vector and we're going to extract certain values using this logical flag. So let me just type it out. How many values have we got in here? 7. So let's just get 7 logical values in our vector. Ooh. And you can see I'm using the shorthand version of logical values. So you can just use single letters as I showed you last time. So finally, let's have a true in there. And if I run this, you'll see that it only extracts the values where the logical subset is true. So the first, fourth, fifth, and last values. Now where this becomes useful is we can use logical statements to extract certain values from a vector. So a logical statement such as ages less than 30. If we run that, you'll see that we are given, returned a logical vector containing the logical flags as to which values within ages are less than 30. So the first, second, fourth, fifth, and last values are less than 30. And now we can use this within our logical vector subset. So we could use ages where ages are less than 30, and that will return us a new vector where the ages are only the ones that are less than 30. And as we saw last time, we could also have multiple logical comparisons. So maybe we want all the values where ages is less than 30 or ages is greater than 70. And you can see that that returns 6 of the values. So the only one that isn't in there is 35 because that is greater than 30 and less than 70. And then again, as we saw just now, we can use this to update values within the vector. So maybe we want all of the ages that are less than 30 to now be equal to 0. And as you can see, ages has been converted to 0 for all of the values that are less than 30. We saw in the last few videos how operations can be used on individual numerical values. We could also use operations on vectors. So let's just define a couple of vectors here to use. So we have foo, which let's say is equal to 1, 3, -12, 5, and bar, which is equal to -1, 1, 3, and 1. And foo and bar are just generic placeholder vectors. They're often used when people are teaching programming languages, and there is a bit of a story behind their origins. But for now, all you need to know is that we have 2 vectors, and we'll just run that to make sure we actually have saved them. And we're going to see how we can do operations using these vectors. Just like the individual values, we can do addition, subtraction, multiplication, and division. So we could do foo plus bar. And you'll see that what that does is it just adds the individual corresponding values of each vector. So the first value is added to the second, so 1 add -1 is 0. The second, 3 add 1 is 4. The third, -12 add 3 is obviously -9, and so on. And this is exactly the same for each of the other operations. So we could have a negative, where each value of bar is taken away from each value of foo. We can have multiplication and division. Now this is all fine for vectors that are of the same length, because it's quite obvious that the operation will be performed for corresponding values of each vector. So the first will be performed on the first, second on the second, and so on. But what if you have vectors of differing lengths? So let's just quickly redefine bar to be a vector that is simply -1 and 1, and see what happens if we do foo plus bar now. So foo plus bar, and you'll see that what has happened is for every value in foo, bar has been used. So -1 has been added to 1, 1 has been added to 3 to get 4, and then this bar vector has been recycled. So we go back to the beginning and we get -1 is added to -12, so we get -13, and 1 is added to 5 to get 6. And just to confirm, we can look at the multiplication as well, just to see if that's what is actually happening. And we'll see that 1 is times by -1 to get -1, 3 is times by 1 to get 3, and -12 is times by -1 to get 12, and so on. And you can also perform operations using just single values. So we could just literally do foo plus 3. And that will add 3 to every value within the foo vector. So 1 add 3 is 4, 3 add 3 is 6, and so on. There are a few other functions that we might want to use when dealing with vectors. So just for example, we might do sum of foo, which just adds all of the values within foo. So 1 add 3 is 4, add -12 is 8, -8, add 5 is -3, and that's what we come out with down here. We also have prod, which gives the product of foo. So 1 times 3 times -12 times 5 is -180. And we also have the mean function, which gives the mean of all the values within foo. So that comes out at -0.75. And that is the end of this tutorial. We've had a quick introduction to data structures in general, and we've looked at vectors in detail. In the next tutorial, we'll move this up a level, so we'll move up into higher dimensions. So we'll look at matrices and arrays. And then following that, we'll look at the heterogeneous data structures, so the ones that can contain more than just one data type. I hope you enjoyed the video. Don't forget to like and subscribe so that you don't miss out on the next videos in the series. Thanks for watching, and see you next time.